Here, we want to find the integral of 2x squared minus x minus 2 over x squared plus 1 multiplied by x minus 2 dx. We want to use partial fractions in here. Note in here that the denominator degree is less than the denominator degree. Therefore, the first point in here does not work. So we will not able to use the long division. Also notice that the denominator is already factored. Notice this is a distinct linear factor. So we will be in form of this one in here. Note this one in here, we cannot factor this anymore. So this is called unfactorable quadratic. So to use the partial fraction, we're going to use this one in here. So it's going to be in form of ax plus b over q of x. So the integrand is going to be 2x squared minus x minus 1 over x squared plus 1 multiplied by x minus 2. That's going to be equal to, again, ax plus b over the first one, which is x squared plus 1. This is unfactorable quadratic. And then plus c over x minus 2. So here we want to solve for a, b, and c. So first I'm going to multiply left side or right side by x squared plus 1 and then x minus 2, which is the denominator in here. So this is going to be equal to 2x squared minus x minus 1 equal to ax plus b multiplied by x2 plus 1 multiplied by x minus 2 over its denominator, which is x squared plus 1 plus c multiplied by x squared plus 1 multiplied by x minus 2 and over its denominator, which is x minus 2. Now let's simplify. Notice that this term will go with this term, and then for c, this term will go with this term. So that's going to be equal to 2x squared minus x minus 1 equal to ax plus b multiplied by x minus 2 and then plus c multiplied by x squared plus 1. Now I'm going to multiply these together, and also I'm going to multiply these together. I'm going to call this number 1 and then I'm going to call this number 2. So for number 1 we have ax plus b and then x minus 2. So first I'm going to multiply x. So we have a and then x squared plus bx. Then I'm going to multiply the minus 2. So it's going to be minus 2ax then minus 2b. For 2, we have c multiplied by x squared plus 1. So I'm going to multiply c inside the parentheses. It's going to be equal to cx squared plus c. Now we have a positive sign, so I'm going to add number 1 and number 2. So number 1 plus number 2 going to be equal to 1, which is ax squared plus bx, then minus 2ax minus 2b, and then plus 2, which is cx squared plus c. Now I want to group x squares together and the x's together and also the constant together. So for x squared we have this term and also we have this term. For x terms we have these two terms. And then what's left off is just the constants. So that's going to be equal to ax squared, then plus cx squared. Then I'm going to bring the x's together. It's going to be bx, then minus 2ax, and then the constant together. So I'm going to have minus 2b plus c. Now I'm going to factor the x squared. So it's going to be x squared multiplied by a plus c. Then I'm going to factor the x. So we're going to have x and then multiply by b minus 2a. And then the constant is going to be the same, 2b plus c. Now remember, this term in here is equal to this term in here. So we have x squared, and then we have a plus c, and then plus x multiplied by b minus 2a, and then minus 2b plus c. And then on the left side, we have 2x squared minus x minus 1. So now I'm going to equate the coefficient. I'm going to look at the x squared on both sides, and then I'm going to equate their coefficients. And then I'm going to look at the x term on both sides, and then I'm going to equate their coefficients. And then I'm going to look to the constant on the right side and equate it to the left side. So for x squared, we have a plus c equal to 2. Then for x, we have b minus 2a equal to minus 1. And then for the constant, we have minus 2b plus c equal to minus 1. Now we have this system of equation in here that will help us to solve for a, b, and c. First, I'm going to number these equations. So we have 1, and then 2, and 3. I'm going to use number 2 and number 3 to eliminate b. So first, I'm going to take equation number 2 and multiply it by 2. And then I'm going to add it to the equation number 3. So 2 multiplied by the equation number of 2 going to be b minus 2a equal to minus 1. That's going to be equal to 2b minus 4a equal to minus 2. Now, I'm going to bring equation number 3, which is minus 2b plus c equal to minus 1. Then I'm going to add these together. So first notice that the b's will cancel each other. And then we are left with minus 4a plus c. That's going to be equal to minus 2 plus minus 1. It's minus 3. Now I can use equation number 1. So I'm going to solve for a. A going to be equal to 2 minus c. And then I'm going to plug that into this equation. So I'm going to have minus 4, and then a is 2 minus c plus c equal to minus 3. So now let's multiply these. Minus 4 multiplied by 2 is minus 8, and then plus 4c minus c equal to minus 3. So you have minus 8, and then plus 5c equal to minus 3. Therefore, c going to be equal to minus 3. Then I'm going to move this to the other side. Going to be minus 8, and then I'm going to divide by 5. Therefore, c going to be equal to 1. Now I can solve for a. A is 2 minus c. A going to be equal to 2, and then c is minus 1. Therefore, a going to be equal to 1. Now I'm going to use equation number 2 to solve for b. So b equal to minus 2a equal to minus 1. Therefore, b going to be equal to minus 1 plus 2a. That's going to be equal to minus 1 plus 2 multiplied by a, which is 1, which is equal to 2. So b going to be equal to minus 1 plus 2. Therefore, b going to be equal to 1. So a is equal to b equal to c, which equal to 1. Now again, this is the value of a, b, and c, and this is what we started with using partial fractions. So let's plug back the value of a, b, and c. So that's going to be equal to a, which is 1, so we're going to have x, and then b is 1, over the dominator, which is x squared plus 1, and plus c, which is 1, and then over x minus 2. Now let's integrate. So we're going to have the integral of 2x squared minus x minus 1 over x squared plus 1 multiplied by x minus 2 dx equal to the integral of this side in here. However, I'm going to distribute the integral for each. So it's going to be x plus 1, and then over x squared plus 1 dx, and then plus the integral of the second fraction, going to be 1 over x minus 2, and then dx. Note that this integral can be simplified. So we have the integral of x plus 1 over x squared plus 1 dx. Now I'm going to split this fraction into 2. So we have the integral of x, and then x squared plus 1, and then plus 1 over x squared plus 1, and then dx. So now we have two integrals. So we have the integral of x over x squared plus 1 dx, and plus the integral of 1 over x squared plus 1 dx. I'm going to call the first integral number 1, and then the second integral is number 2. First, let's solve integral number 1. We have x, and then x squared plus 1 dx. Here, this integral can be solved using u substitution. So u is going to be equal to the dominator, which is x squared plus 1. Therefore, du is going to be equal to 2x dx. Now I'm going to move this to the other side. So it's going to be 1 over 2 du equal to x dx. Therefore, this integral is going to be equal to, again, x dx is just half du. And then 1 over the dominator is just equal to u. So it's going to be 1 over 2, and then the integral of 1 over u du. Now that's going to be equal to 1 over 2 natural log of the absolute value of u. Now, let's back substitute the function of u, which is x squared plus 1. Therefore, this integral going to be equal to half natural log of the absolute value of x squared plus 1. For number 2, we have the integral of 1 over 1 plus x squared dx. Notice this is just the derivative of arctan. Therefore, the antiderivative is going to be arctan of x. Now, let's move to the left side. So this integral here is going to be equal to 1 and 2, which is this term and then this term. So that's going to be equal to 1 over 2 natural log of x squared plus 1, then plus arctan of x, and then the antiderivative of this integral is going to be plus natural log of the absolute value of the dominator, which is x minus 2, and then plus the constant c. And that should be the antiderivative of the given integral.